quick things that I want to make sure logistical wise that you are comfortable with and aware about. So we have our first day of ISASP preparation coming up tomorrow. You may have heard about this in your first period class, but I just want to make sure that it's very clear. So tomorrow we are going to meet in first and second period just like normal. The times are adjusted a little bit from what we're used to. So I will see you at 9:37 as opposed to at 9:45 or 40, whatever it is. Maybe that's about right. Anyway, and then after you go to that class, then you will actually go to your ISASP testing location. Okay? Those were assigned based on grade and last name. And they are, I believe, available for you to see down by the counseling office and also in the Commons. Is that right? I think that's where people were saying last period that you can find them. So you need to make sure, just one second, let me finish this up, that you know where to go. And after second period tomorrow, then you will go to that testing location. We are not testing tomorrow, okay? Tomorrow is to make sure you know where you're going, to know some of the expectations and rules for the test, and also to make sure that your computer is ready to go, okay? To be clear, tomorrow you need to bring your Chromebook and it needs to be fully charged. Also bring your charger. Does that make sense? If you happen to use a non-school issued Chromebook for your day-to-day Chromebook needs, okay, you need to make sure that you have a school issued Chromebook, like the one that you got from the library at the beginning of this year. That is the only one that will work, okay? So if you have a fancier one for whatever reason, and I'm not judging, I'm just saying, if you have that fancier one, don't bring it to school. The one you need is the one that we gave you from the school, okay? Does that make sense to everybody? All right. So again, tomorrow after second period, you will be going to your ISASP location. If you don't know where that is, look downstairs at some point today, okay? When you come in late, you got to just go with it. You don't be fussy because we're moving now, okay? After that, we go to fourth period so that we can get our lunch done. And then we have third period after lunch tomorrow, which is a little bit funny. And as you notice here, there is no formal Liberty time tomorrow, okay? So we just go all the way down to 4:05. So our Liberty time is built in the morning for ISASP. Questions about the logistics of that? We good? Go.
Did you say there was something like, or on announcements, wasn't there something right about the lunches, like who's going to be in the lunches and stuff?
So that's during the testing time.
Okay.
This, you will just be in your regular fourth period class. So we have this like preparation day tomorrow. We have another preparation day next Monday, a week from today. But then on the testing days it's actually just the first testing day that we have a funny lunch schedule. Yes.
So then we're also going to be doing normal classes during the day.
Yes, we will. Yep, both tomorrow and during the testing days. Yeah. But it'll be like when on the actual, and I don't want to throw it all at you right now, so I'll show it to you in a few days. But on the testing days on Tuesday and Wednesday of next week, I think Tuesday we have like periods 1, 2, and 3, and then on Thursday we have 4, 5, 6, 7, or something like that. Like yeah. So it's a little bit funny, but we will still see you. Yeah. Okay. Other questions? Logistics? Zach, you had a question.
So I checked the papers and didn't say
it didn't have your name. So I would check in the counseling office, and they can help you out. Does that sound good? Yeah, that's a good question. Yeah, if for some reason you don't see your name or you have some other issue about like you don't have a Chromebook or you don't know where your locker is or any of that, I can help you with the locker thing. But other than that, okay, let me know and I can help you or talk to the office. Yeah. Okay. Any other ISASP related questions? All right. Another FYI for you about tomorrow is that tomorrow in this class, we are going to have a short quiz. Like I'm thinking like 5 or 6 questions. I've looked at like a draft of it, but I haven't like finalized it. So I can't tell you exactly how many questions it is, but there will be a quiz tomorrow. So pay attention to that. Write that down in your notes if you need to, whatever you need to do so you don't forget. You have a quiz tomorrow over migration and natural resources. Okay? Many of the other classes are doing it today, but I didn't tell you about it, so I didn't feel like that was a fair deal. So tomorrow, migration and natural resources quiz. Okay? All right. Now we're going to get into stuff and actually do things. On Friday, I need to remember because I can't remember exactly where we ended. You have your blue sheet out now. If you didn't get it out already, go ahead and get it out now. It looked like this, right? Your blue sheet, we were writing down notes. We did at least 2 demos. Is this sounding familiar to you? We broke the paint stick. We crushed the can. And then did we watch the video with the egg that went into the flask? Do you need one? Is that what your hand is up for? Yeah. Did we talk about it at all or no? No. Okay, so we need to talk about it still. Would you like a reminder about what happened? Would that be helpful? Is anybody saying yes? I don't really remember. Okay, let's go back and watch the video quickly. It's a super quick one, but let's go ahead and watch it here real quick so that we know what's going on. It had cute music, right? Oh, there it goes. Okay, so we're watching carefully here, friends. So they put hot water into a bottle. Put a hard-boiled egg, it's peeled. The egg starts wiggling around. And this part you have to be a little patient about. Oh my gosh! Look at it go! All right. So that's what happens. Again, I wanted to show you with your own 2 eyes, but my eggs were too small. So what's that? So there's a really fun little technique that you can use, and we'll talk about it in just a second. How about so that I can show you how? Yeah. Or you can just like fork it and break it. The ones that we had just kind of broke when they went in. Anyway. All right. So let's go ahead and take a look at this demo. So I didn't have you write down a prediction because we already saw it once. So let's kind of skip the prediction piece and write down your observations right now. You and your pencil, write down your observations. What did you see in that video? What happened to that egg? Hint, it didn't just stay on the top. Once you've written something in the box that says observations, check with the people that are next to you and see what they wrote in the box that says observations.
Oh, actually,
Squeezing its way into the top.
I can move your table. Would you like me to move it again? Okay. This is your table. These are the people next to you. Fair? Awesome. Thanks.
Hey,
Eric. Thanks. All right. What did we observe? Hayden, what did you see? What happened? The egg fell into the bottle. It fell in. But it wasn't supposed to fall in because it was sitting on the top. So is there another verb that we could use besides fell? I mean, because I think fell is accurate in that it did go down, didn't it? But generally when I see the word fall, I think about just something that just like, falls. Right? Let's go here and we'll go this way. Go. It squeezed its way in. Squeezed its way into the bottle. What did it do? It slipped through. Should I say the opening? Just because otherwise I'd be like, oh, it slipped through the bottle. Like, you know what I'm saying? Like, yeah. That's cool. Yeah. It sunk into the bottle. I think all those seem pretty accurate. It fell in through that opening in some way, shape, or form. It doesn't make sense, though. If I just take an egg and put it on top of a bottle, it doesn't make sense that eventually it's going to fall in if the bottle is the same, or is the hole of the bottle is smaller than the egg itself or the thing that's above it. What's the explanation, friends? Magic is not the answer. Magic is not the answer to anything in any of my classes. So if you at all intend to take physics ever in your existence at Liberty High School, don't use the explanation of magic because it won't work. There's always science behind things. We'll start here. We're going to go this way this time. Go.
So hot water is less dense, so it was trying to escape around the egg. So
Okay, so let's write this down. So we put hot water into the bottle, right? And the hot water is less dense. The hot water is less dense. Is the water less dense? And I don't disagree with the density is absolutely in there, but I just want to make sure that we're really thinking about things. If the hot water itself was less dense than the air, where would the water go? Up. And that's not what we saw. Are you with me there?
the heat was less dense.
Okay, so the hot water, what did the hot water do to the air inside the bottle? I heard a lot of things that kind of were like not really loud. So the hot water made the air humid and it made it more watery. What did the hot water do to the air in the bottle? What did it do to the temperature of the air in the bottle? It increased it, right? Made the air warmer. And what do we know about the warm air? It rises because it is less dense, right? So the hot water into the bottle, and the hot water made the air warmer, and the air is then less dense than cool air. And then what happened to that hot air? The hot air inside that bottle, what did it want to do? It wanted to spread out, it wanted to get around the egg, right? So if we draw this bottle, and I would like you to have this in your notes as well. So here's your little bottle. Mine's kind of like the Erlenmeyer flask there. And then I've got my egg. Okay, I'm a little Dr. Seuss fan today. And I've got this hot water. Which makes hot air. And that hot air wants to get out, right? So that hot air kind of seeps through here and it seeps through there. And hopefully, you all did your homework because I'm going to come around and check in a minute. Hopefully, on the back, you watched that video and you answered some questions. My question for you right now is, tell me about the pressure now inside the bottle if air has been escaping because it wanted to rise. Tell me about the pressure here. Is it high pressure or is it low pressure? It's one of the two.
It's low.
It's one of the two. You seem you're like, are you hedging or are you?
It's high.
It's high.
It's not high.
It's low.
It's low.
The air rises.
The hot air causes. You had a 50-50 shot, I think is what they're saying. Less dense than cool air. So what's going to happen? That air escapes and results in or creates low pressure inside the bottle. Have we seen this in another demo that we did on Friday? The can situation, I'm going to just go back up there for a second here, okay? The can had that warm air as well that cooled down really fast. So it wasn't that the air escaped, but it cooled down really fast, became more dense, and took up less volume. Because it took up less volume, again, this situation here, where we said creates a vacuum, we could also have written, and I'm going to write now, and you might want to as well, write that this is a low pressure situation. Okay? Vacuum is the epitome of low pressure. It is as low pressure as you can get. No pressure almost. This vacuum business is what we're talking about. Warm air escapes. It creates this low pressure inside the bottle. I'm back on the egg in the bottle. Sorry that I'm jumping around so much. I just wanted to make sure you got that with the can. Low pressure inside the bottle. What kind of pressure do we have outside the bottle? High, or at least higher pressure, right? And so we've got air that's pushing on the egg. Pushing on the egg in all directions, but the air that's pushing down on the egg, what's happening to that push? What's it doing to the egg? Yeah, so it's not sucking. That's the thing. It's pushing. And this is it's kind of like this common joke that we have in science, right? That science doesn't suck. Nothing in science sucks. It's always a push, right? There is no, that does not happen. It was a good noise though, wasn't it? Yeah, that does not happen. Really what's happening, friends, is that you have a force. The air is pushing down on the egg, pushing down on it from this place of high pressure. So we can say then that high pressure air outside the bottle pushes the egg down and into the bottle. Okay? That's what's going on. The air pushes on the egg. Remember, we did the math to figure out how much air was pushing down on that little piece of paper on Friday when I swacked and I broke that paint stick. Same deal. Okay? Air is pushing down. That's what's causing the egg to go down. Right now, we are going to do I labeled it a capture question, but it's actually on the back of your sheet. So what I'm going to do two things at once here. On the back of your blue sheet, there are some questions that you were supposed to answer after watching a video. Okay? So I'm going to come around to check those in. Okay? If for some reason you didn't do that, you're going to do that tonight and give me a green card tomorrow and it'll be fine. Okay? The link is on Canvas. So make sure that you do that. What I want you to do right now is that little bottom part. I'm labeling this capture question 7.5 because we're doing it in place of a capture question. Okay? You're going to work in pairs. So you're working with the person you're sitting next to. Deronda and Jackson, I'm going to have you guys be a pair. Okay? Jacquez, I'm going to have you guys be a pair. And I think, Hayden, I'm just going to have you guys work as a trio there. Is that okay? Is that all right? I'm sorry, I still have one other third pair person. Okay? So, I want you to take a look at this thing real quick. It says, make a paper bridge. One piece of paper, 2 books. So I've got a bunch of physics books there. I've got a bunch of earth science books there. So you're going to grab 2 books. You can use your little blue piece of paper. But before you do the experiment, so you're going to blow under the bridge and find out what's going to happen to the paper. Before you do the experiment, I want you to make a prediction. I want you to write something down. Make a commitment. What's going to happen? And then after you do that, do it, and then make an observation. And then continue to answer those questions. I'm going to give you about 5 minutes, and then we'll regroup.
Okay. What's your position? No, I know, but like,
So let's come on back together. I think that most of us are there. Maybe not quite everybody, but we're getting close. Honest answer. Honest answer. What was your prediction prior to trying it? Again, I don't know. What was your prediction prior to trying it? What do you think?
I thought we were just gonna blow the paper across the table.
So you thought that the paper would travel across the table?
Yeah. Is this better? That's because I want to get called.
Geronda, what did you think was going to happen? Thought it was going to blow away? Yep. Other answers?
I thought it was meant like me upwards.
You thought it was going to go up? Other answers, yeah. Just like, yeah, yeah. I like the word flutter. That's good. That's very descriptive. Other different predictions that you had? Is this what happened?
No. I mean, it fluttered.
What did happen to it?
It stayed where it was.
So you have to be careful when you're doing this, because if you don't look while the air is going underneath, then nothing happens. Then it looks like nothing happened. Before and after. But if you look while the air is moving quickly underneath the paper, what happened to the paper? It went in. It sunk down.
Really?
Yeah, it really did. Get it out and try it again one more time. Just because it's really interesting to see.
I mean,
Do it real quick.
okay.
Because I think it's important for you to see. It's exciting. So the observation, the paper sinks. Or maybe it bows down. Let's try it. Make sure we see it. All right, you ready? Make it happen, friend. You're blowing off the-
It went down a little bit. I saw that. Cute. All right. Cool.
There you go. There you go. It'll be great.
For once, I'll really show
Did you see it?
I saw it.
Isn't that weird?
That is amazing. That's
It is kind of strange that by blowing air underneath, a piece of paper, it gets the paper to sink down. And it sinks down a lot. Why does it do that? Let's use the science that we've just been talking about. Why, upon further thought, is that result not completely surprising? It's not completely, it might not be expected, but it's not completely surprising. Get us started. Yeah, so the air under the bridge is moving really fast, right? And as a result, tell me about the pressure under the bridge.
low.
It's low pressure. Does that make sense? Those air molecules are not there to push up on the bridge like it was before on the piece of paper. Yeah, so it creates a low pressure area under the paper. And if you've got low pressure under the paper and that's relatively high pressure above the paper, what is the air, that column of air that goes up? What is that air doing to the piece of paper? What is the air above the paper doing to it? Pushing down, right? 14 pounds per square inch or something crazy like that, right? It's a lot. Yeah, we did the math on Friday, didn't we? I think.
Yes, for what?
How much the air is pushing down on us?
Yeah.
Yeah. So it creates a low pressure under the paper, and the air, friends. Stop. Okay. Okay. Seriously. I like being interactive in class. Like, I do like that. But we have to show kindness all the time. Got it? Okay. Air pressure above the paper pushes it down. Is that making sense? So it is literally the air above the paper that's pushing it down. It's not the air below that's pulling it down. It's a push from above. Same kind of thing with the egg in the bottom. So it's kind of a fun little experiment to do, right? You can amaze your friends or whatever. Take it home. Your parents say, "What did you do at school today?" "Oh, I did this really cool thing." You can totally mess with their heads, right? This is an opportunity for you to do this. Are you guys okay over here? Because there's a lot of like quiet conversation that's really not okay with me. Okay? You're in high school. You need to act like you're in high school, please.
Yes.
Okay? Okay. Explain how you think that this has real world applications. This is why I care. I mean, this is cool, but why? Why do I care?
Because like in windy places, when the water's or when the wind being across the water, it doesn't like lift the bridge off.
Right. How many of you guys have ever seen a picture or seen the Golden Gate Bridge in San Francisco? Do you know what I'm talking about? The bright orange one? Yeah? Okay. You're gonna be there in 2 weeks? So we're gonna talk about 3 weeks. Okay, let's talk about what's going on there so that we really understand it. Question? What's that? It's like a reddish orange. It's goldenish. Yeah. So has anybody ever been to San Francisco before? Windy place, right? Especially on the water. Like super windy, pretty cold in the summer if you go there. It's pretty chilly. And right on the water, it's super windy. Now, some bridges are designed, like here's the roadbed of the bridge, and then it has these nice pylons that hold it up, right? And so then there's water down here below. Okay? And so now if the air goes really, really fast underneath, and the air starts pushing down, these pylons are here to pull it up, right? To hold it up. So it's not going to go anywhere. Do they have these underneath the Golden Gate Bridge? No, they do not. The Golden Gate Bridge is very, very long, and there are two at either end, but there is nothing in the middle. The reason for that is because there are really, really big boats that have to go underneath that bridge. And if there are pylons stacked across, they're not going to be able to get through. So the Golden Gate Bridge is a really, really long bridge, okay? And there's really cold water down here with sharks in it. Nom, 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 okay?
There's sharks in there?
There's sharks out
Yeah. Alcatraz is very near there. People trying to swim from Alcatraz back. Nom, nom, nom. Yeah, not going to happen. All right. So there's water here. It's very windy, which means that as that wind goes underneath, what's going to happen to this bridge? It would collapse, just like your little piece of paper collapsed, right? It needs something to pull it up. It doesn't have pylons like this, though. What does it have that holds it up?
Really tall.
So sometimes I'm going to draw an arch bridge real quick for you. So often arch bridge, well, there are kind of two arch bridge designs. One is the underneath, like this. And that's kind of doing the same thing that the pylons do, right? They're pushing up. This pushes up, and then it also helps to push out. Okay? And there are other arch bridges that go up above, right? So you have an arch, like your roadbed like this, and then you have an arch like this, where, again, it's kind of pushing this way, this way. The one in San Francisco is not an arch, though. Does anybody know what it's called? It's called a suspension bridge. But yes, you were drawing it beautifully. Yeah. So there are two really tall towers, and those towers do go down. like that. But then besides those two towers, because that's not going to hold it up, they use cables like this, right? So it looks something like this. And then there are cables that go down like this. Does this look kind of familiar to you? Have you seen something that looks like this? Yeah. Okay. And so the way that this works is that there are really, really large weights over here, counterweights. Okay. So if we imagine the air is going underneath, blowing really fast, and basically the air above is pushing it down. That's exactly what you just saw. But to counteract that, these cables, the little ones, are pulling up. And the reason that they're pulling up is because these long cables are really, really tight. And they're pulling down like that. Does that kind of make sense? So these cables right here are pulled really tight to pull the whole thing up to prevent it from collapsing, not just under its own weight, because it's a really big bridge, but also because when that wind goes right underneath it, it's going to sink really far. So that's a different bridge. That's called the Tacoma Narrows Bridge. That was in Washington. That one was the same kind of bridge as this. Okay. It had issues with that. The other problem with it is that it was being pushed at what they call a resonant frequency. So it was doing the same thing that when you like push your little brother on a swing, you know, you push them on the swing and they get higher and higher and higher every time you push them. You know what I'm talking about? So it's the same thing, except it was the wind that was pushing the bridge and it started swaying and breaking. And yeah, different bridge. This bridge is safe. That bridge only lasted like 3 months and then collapsed. Take physics. We actually literally 2 weeks ago just watched that video and talked about why it happened.
Oh, we did watch that.
Nobody. No people died on it. It's amazing. Right? Because there was nobody on it. No, there was a guy that ran, but did not. He made it. Yeah. There is now another bridge over the Tacoma Narrows Strait, but it's not that bridge. Yeah, it's a different design that wouldn't do this. Yeah. All right. Questions, issues here? Does this make sense? Okay. That one in Virginia. I don't know that story off the top of my head. Sorry. If you look it up for me, Colin, and let me know, because I don't know the story and I'd like to learn it. I like bridges a lot. I think they're interesting. So yeah. All right. We doing okay? Ready to move on to new stuff? So we spent some time on Friday talking about air. Today we're going to get into the natural resource part of air. So we were talking about like the properties of air. Now we're going to get into the natural resource part of air. We're going to start by doing a reading. So everybody's going to need their Chromebook out. A friendly reminder, if you have not yet finished your notes from that video, you need to do that as soon as you can, because I'm going to put those grades in, and every time you know something, it's that. Okay? But you can put that blue sheet away for right now. Get your Chromebook out, open it up, and go to Canvas, please.
Am I on that?
We'll check. We'll check right now. I think you should be from my. Okay, so I'm going to pause you all for just a moment. If you're not finished reading or watching, that's totally fine. But can I grab your attention up here for just a moment? Okay. So again, once you've logged in, you've read that, all of that good stuff, the next thing I'm going to bring around is a sheet of paper that's got this on it on the front. And I'm going to bring this to you right now. Okay. There are 3 questions on here. Please listen just for a moment. Please, can I have everybody's eyes up here for just a moment? Okay. There are 3 questions on here that you can answer based on what you've read and watched. Okay. What I'm asking you to do, though, is a little bit different from what you do sometimes when you're reading and answering questions. And that is that I actually want you to find evidence in the reading to answer the questions. I know that you're asked to do this sometimes in English and in social studies, so the same kind of deal is true here. Okay? So there's a question, and then it says, what textual evidence supports your answer? Directly quote or paraphrase the author to find a solution or an answer, and then tell me why the evidence is relevant. So there are 3 questions with 2 parts each for those. Okay? You've got some time to work on this right now. If you do not finish this in class today, it is homework. I want it to be done by the time you get here tomorrow. Does that make sense to everybody? Okay, so I'm going to come around and hand this out to you. And you can go ahead and get started on it. This is an individual thing, though. This is not you and your partners. This is you and your brain, okay?